This is the actual lesson part of 3-3. And in 3-3, you'll be building on your skills of making perpendiculars and putting them together with the concepts that go with the conjectures so that you can build more things with the skill you have. So the objectives are to be able to find shortest distance, and that's going to be shortest distance from a point to a line. That should have been in parentheses, from a point or a location to a line. We also want to be able to construct perpendiculars anywhere, not just bisectors, and construct altitudes. So in your first thing we need to think about is where the shortest distance between a location and a line are. To give that some context, we're going to have Farmer Bob over here. And Farmer Bob is standing at a location, and points mark locations. And Bob needs to get to the road and the shortest path possible. And by thinking about how he does this, we'll know then how to calculate a shortest path or construct one. If Bob takes different angled paths as he walks to the road, each one of those segments, the second one's shorter than the first, so that would be better. But the most direct path, meaning the shortest path if he's able to, would be from that point perpendicular to the road. So perpendicular to the road would be like one side of a right triangle, and any of these other green paths would be like the hypotenuse of a right triangle. They would be longer than that trip that's red. So when we're looking for shortest distance between a location and a line, we'd be looking for measuring along the perpendicular segment, not the perpendicular bisector, because lines can't be bisected. The perpendicular segment from that location to the line. And again, pause the video anytime you need an extra moment to take the notes. We're going to build on that idea and say, well, how do we construct perpendiculars to different places? So how would we construct that shortest distance if we either knew where on the road we'd like to get to or where the farmer's standing? So there's two perpendicular constructions we need flexibility with. If we already know the location on the line and we'd like it perpendicular to the line at a particular place on the line, or the other one perpendicular but from a place that's not on the line. So this is depending on what part of this we've got. So our sketch, what this would look like is that we've got a line and then we've got a point on the line. We'd like the perpendicular to come right through there when we construct it. The problem is that's not a midpoint, so doing a perpendicular bisector won't make that happen. That isn't the midpoint. So here's our plan. Our plan is to try to force that point right there to being a midpoint. And to force into being a midpoint, I would take my compass and just mark off the same amount on either side from that point. Therefore, I've now forced that the red point on my picture to be a midpoint between these two endpoints. Those green endpoints, then, I can construct a perpendicular bisector, treating those as a segment, so that when I do that from either end, and remember this is a sketch, this is not my final construction, that my perpendicular will come right down through that point. So that's my plan. Let's go carry that out with a compass. And remember, you can also watch that on the construction video that you have access to. So I'm going to slide this down a little bit. I'm going to first get my compass, and with my compass, I'm going to make that point into a midpoint. I'm going to set the point down, pick a distance that I'd like to open my compass up, and it doesn't need to be a large distance, but it's going to need to be the same distance from both sides. Swing it on that side. I'm going to rotate my compass around without changing its setting, and I'm going to swing that same length from this side. I've now forced that point in the middle to be a midpoint. Doing that, I can now do my perpendicular bisector construction between my two green points. So now I'm going to treat this new location as an endpoint. And as I do that, then I need to open my compass up to a little bit more than half the distance of that segment. I'm going to go above first before I swing. Swing my compass once there, and if you like full swings for perpendicular bisectors, you know you can certainly do that. And then I'm going to put my point there, and again, arc swing, so that I'm doing a perpendicular bisector between those green points. And I'm going to go get my straight edge to connect up between those two points that we just created so that there's my perpendicular to the line. It's not a perpendicular bisector of the line. Lines don't have middles. Again, pause this or go watch it on the construction video if you need to. The other thing we need to do sometimes is make a perpendicular through something that's not on the line. Maybe eventually that will be the vertex of a triangle even, this point up here. So we need to get that perpendicular to go through that, but again, that's not a midpoint. So we need to somehow force it to being an equidistant point. So my plan, again, this is why we're sketching first, constructing second, to do the brain power part first. My plan is to get from that point to swing a radius, an arc, so that I will hit the curve twice. Sorry, I hit the line twice. And I may have to extend the line, there's no problem with that. Use your straight edge though. And from those 2 points, I already know that this point up here, I'll color it a different color, that's equidistant from those 2 points. So from those blue points now, I can do a perpendicular bisector because I'm guaranteed that that red point is on the perpendicular bisector. I set it up that way. Then I'll come and do my perpendicular bisector construction. At this point, I already know 1 point on my bisector, so I don't need 2 sets of arcs to create 2 new points. I really only need a second point on my perpendicular bisector. It's okay to have more. Then I'll use my straight edge so that I can get a perpendicular through that point that was not originally on my line. It looks kind of a mess, so let's go down and try this in actual construction terms here. And again, I'm going to stretch out this line a little bit. I may need it. Bring my point down a little bit. Oops. Haha. Okay, so here's the plan. From that point, same thing we did last time, but the point's not on the line this time. Let's stretch out my compass a little bit and start it over here. I need that line to hit I need that curve, sorry, to hit my line twice in 2 places. Those places are equidistant from that point. So these 2 points form the segment that I'll now go do a perpendicular bisector from. And that perpendicular bisector will contain that point. So I'm going to here, stretching my compass out more than half, rotating it a little bit. Okay, and I'm going to go ahead and I can either do my arc set above or below. Then I want to switch it. So I can come over here, do my arc, pull it away in that location that they just made, that equidistant point on the other side, and again, you could have done it above or below, connects with the point we already knew was on the perpendicular bisector. And it's going to come down through those. So as we make them, right, and mine's a touch off because of the thickness of my marker. Again, pause that and go to the construction site if you need to see it again and again and again. How we use those then is to make things like medians we did yesterday and mid-segments, but this time altitudes. Altitudes by definition are segments that connect the vertex of a triangle perpendicular to the opposite side. So if I were to sketch all the altitudes in this triangle that I've got drawn here first, if I were to sketch altitudes A and then perpendicular to side BC, so that would be the look of one altitude. There'd be 2 more altitudes in this triangle though. One of them is going to go from B perpendicular to side AC, and one of them is going to go from C perpendicular to side AB. So when we decide we need to put in altitudes, sometimes they're going to fall outside the triangle. So I've got the second triangle labeled ABC here. And when you go to put in the vertex from A, or the altitude from A, that will be from point A, and we're going to have to go perpendicular to the other side so our altitude doesn't surprise us where it falls. However, when we go to put in an altitude from C, this is where that second part of the definition comes in. And so don't leave that part out when you define altitude. It's necessary. I can't go from point C perpendicular to segment AB. There's no physical way to make that happen. This line segment from A to B doesn't have a perpendicular path to point C. So that's why it says, or the line containing. I'd have to extend the line with my straight edge so that I have a longer side length there. And this is that part where it will come perpendicular to the side containing, or the line containing side AB. And therefore my altitude will be outside my triangle sometimes. So when we go to construct this, we need to think about Farmer Bob. We've done this construction before. So if we would like to get an altitude, we'd like to connect this point perpendicular to this road over here. It's a side of a triangle. But remember Farmer Bob? Farmer Bob said that to get the shortest distance or the perpendicular to something from his location, we had to, remember we swung the circle to hit the side twice and then did a perpendicular bisector construction between those two new points so that our perpendicular came right through. So that's going to be our plan, is go back to how we constructed those perpendiculars to points not on the line. We're going to follow that same plan. And the plan was, get our compass. Decide if we need to extend that other side first. In this case, I don't. My altitude, I imagine, is going to run right where my cursor is going. It's going to stay inside my circle. So, take my compass, start it at that vertex point, open it up enough that when I swing it, it needs to hit. So I'm going to check. It's not enough. It's not going to hit that other side twice yet. So I need my compass open more than that. Again, I'm going to do an eyeballing. I think it will hit twice if I keep it where it is. So I'm going to go ahead and swing that arc so that I cross that opposite side twice. I may need to extend the opposite side for that to happen. From those two new points then, I'm going to construct my perpendicular bisector. Open up my compass more than halfway. I only need one additional point, we remember, but it's okay if you want to do two. Oop, I'm a little bit worried that's not going to be big enough. So give me a second to move that, and let's undo that, and let's undo that, and let's try again. Because I'm a little bit worried that's not going to be long enough. It wasn't more than half my distance, and that's going to happen sometimes. You just got to start again. So there's my first swing. I think I'll be able to get 2 points if I'd like. Only one's really necessary. Okay, and my compass swing to put that in. Make sure they cross. Whoa! Compass doing the splits, right? So then my altitude there with my straight edge would come down through this point, and if I needed to, come down through this one, but I definitely have this for accuracy. So my actual altitude stops there. If I only had that other one, I'd need to put that in for construction's sake to show where I got the intersection. But the actual altitude segment then is right there. You definitely want to look and see what happens when your triangle's obtuse, because that altitude's going to go outside, and you may want to rotate the paper to help your brain see that better. So your construction assignment is from 3-3, and please remember to use the videos or go back and repeat parts of this video to help you out.